We face a lot of different challenges and problems now in US and around the world. Our infrastructures are aging. It includes pipelines, it includes a network of bridges. We have several issues with aviation structures. Fatigue and corrosion are major issues now. For all of those things, we believe that there is a huge need to create non-destructive evaluation methods that can cover and provide information for the health and integrity of those infrastructures. The ISNDE lab stands for Intelligent Structures and Non-Destructive Evaluation Laboratory. This is a lab in College of Engineering, in Civil Engineering Department. Our final goal is to make our community safer and our world a safer place to live. My name is ISNDE Niri. They usually call me Dr. Niri because it's easier. I'm director of this lab. This group includes a postdoc, 3 PhD students, 2 master's students, and several undergrad students working together on several different projects. We have a lot of partners, and we got a lot of donations from the Department of Energy and industrial partners. I can maybe categorize the research that we are doing or projects in 3 areas. The first one, I would say, the robotic inspection and bio-inspired sensing. We are collaborating with Arizona State University Robotic Group on developing a robot that uses friction instead of using wheel. So the novelty of this robot is twofold. It can grab and climb without need for magnetic wheel. The second very novel thing in this particular robot is we integrate mobility component with NDE sensing system.
We have designed a robot which is inspired by the lizard. This robot has 2 grippers. Each grippers have 4 fingers, and acoustic transducers are embedded and attached to each of these fingers.
As the robot is climbing, it can image and find defects in tubular components.
That way, the robot can do all of the testing, essentially, while the person just kind of sits back without having to, for example, touch very hot surfaces. We want to make it more safe, more autonomous, more easier, essentially, for humans.
Tap testing systems, current ones, are not very effective to finding a deep debond or delamination or inclusion. We are working with Duke Lamar Center, and we are considering an animal, II. This animal has particular sensing capability, very advanced one for near field. It taps on the tree bark to find the deep cavities.
And here in this lab, we kind of mimic the tap scanning of this middle finger using a hammer to evaluate the effect of the external ear of the animal. We have 3D printed the animal from a CT scan.
So the second thrust that we work on in this lab is infrastructure monitoring. So structural health monitoring is a solution for making infrastructure safer.
My main research is non-destructive evaluation using ultrasonic waves. What I hope is to introduce this tool to help assess the integrity of the structures, like airplanes, so we don't see any failures in any circumstances.
We are working with the Department of Transportation on a project. So we use machine learning that can predict the damage to infrastructure based on the loads that is going through those bridges.
Currently, I'm working on incorporating weather data into a machine learning algorithm in order to predict, whether or not a bridge has become structurally deficient. So we look at the bridge's location, and then we correlate that to a certain amount of weather data. So we're looking to see if that has any effect on structural deficiency of bridges.
So you can see that on the infrastructure side, we gather those data and we analyze those in a smart way for, first of all, find defects and evaluate the damage, and on top of that, do some sort of asset management for the network of infrastructures here. It's a major problem we have right now in additive manufacturing is there is not reliable non-destructive evaluation method or quality control methods. We are using sensing and non-destructive evaluation during the additive process. We collect the data, and then we try to find correlation between those data that are collected during the build with the quality of the part. For in situ quality control, we use thermal imaging, we use acoustic emission, and we use ultrasound.
My focus area is on real-time monitoring of additive manufacturing materials. Also thermal image processing. I wanted to include some thermal image processing also with the real-time monitoring.
We collect all of those data, and then at the end, we do the quality control on the part after the part is built. And then you have the quality information, you have measurement sensing data, and then we want to create this algorithm that can find this correlation. You can, in real time now, collect the data and sensing information. It can give you information about the quality, and right away you can use a feedback control to somehow correct and take some action to correct the defects in real time. Many times students, when they look at civil engineering, they just think about bridges maybe, different types of structures. But with this research, we showed that we can bring a multidisciplinary areas of research and education in one location in civil engineering.
In this lab, you are not limited. You are getting exposed to a variety of topics.
I think it's extremely gratifying. You're constantly being pushed to learn something new. You spend a whole lot of time trying to get something to work, and then it finally works. I guess it instills a certain level of confidence in the students that, you're actually going to be working on something that's going to be, making a difference out there. And just to be around people that enjoy doing what they're doing motivates me to work hard on whatever research project I'm on.
Students are working together very nicely in different areas. They help each other and they complement each other. So those are the things that make this lab and the environment, this group is very vibrant and dynamic and very friendly.
The good thing about the ISNDE is we are a team and we learn team working here. We can kind of support and help each other on our research areas.
Everyone always says good morning. They always come up to you and say how you're doing. I think the biggest part is just kind of, it feels like a mini community in here. Just everyone's kind of supporting one another and everyone's just really kind.
Whenever I call, immediately they will come and help us. They are helping people. Everybody is a friendly person here. So the working environment feels better.
It's a very nice community to be part of. And with Dr. Neri, I know I can go to him if I have any questions at any time, and he'll be there to answer all my questions.
We as educators really can help people. I feel really good when students get successful and find jobs and have a better future. It's an amazing job.